Okay, let's consider some forces. Let's pick a camel standing on a road. Why not? Here's a camel standing on a road. Like everything on Earth, it has weight. It has a force acting downwards due to gravity. It would fall down if it wasn't for the road pushing back, a reaction, which is a force which acts in exactly the opposite direction with the same force, means the camel stays still. What would happen then if the road was taken away, if that reaction wasn't there? Well, the camel would fall downwards. It would free fall downwards because there's nothing to stop it falling. Well, let's consider some cars now. This Mini here, if it starts moving forward because the engine driving it forward, it will start to accelerate. There is no frictional force or air resistance when it's going at very, very low speed. But as it builds up speed, you'll find that there'll be a force acting in the opposite direction due to the air resistance, due to the friction. So it tries to slow it down, but at this stage it is still accelerating because you can see the arrow going forward is bigger than the arrow going back. Eventually, the arrows will balance out. They will be equal and opposite. So this Mini now travels at a steady or a constant speed. It needs to keep the force forward to maintain the speed, but the force backwards is the same size in the opposite direction. If the Mini now driver then puts his foot on the brake, takes his foot off the gas, there is no force going forward. The force going backwards brakes will slow him down until eventually he stops. We talked about resultant forces. These are quite easy. You just consider the size of the force and the direction. So this first person here has been pushed in both directions. You can see that this force is bigger by that one. You take one away from the other in this case, so the resultant force would be 400 newtons that way. If you look at the second person, you can see the difference is 100 newtons that way. And here you can have more than one direction. These two 700s would cancel each other out, wouldn't move left or right, but he would move upwards with a force of 200 newtons. And this last one, very similar. You can take the top force and the bottom force away, and it would be pushed up with a force of 50 newtons. That's what's meant by resultant force, the combination of forces. There is an equation that links force and acceleration. Basically, the bigger the force, the bigger the acceleration. So if you look at these two sumo wrestlers, you'll see that the one on the left is pushing the other one, bigger arrow there, he's going to accelerate towards the right. To work out the size of the acceleration, you can use this equation. Again, you can put it into a triangle if you want to rearrange it. And the force is actually equal to the mass in kilograms times the acceleration. So a bigger force for a bigger mass with a bigger acceleration.